Hi everyone, today we are here for another DBMS tutorial video. But before we begin to our topic, I would like to explain what we have done so far in this DBMS tutorial series. In my first DBMS tutorial video, I have explained how information systems impact to business organizations. By watching my second tutorial, you will be able to enter to the DBMS world without any doubt. It has included all the basic DBMS aspects you need to know. My latest uploaded DBMS tutorial is Database Design Process and Data Models. In that video, I have explained the phases of database designing and introduction of data models. In this last uploaded tutorial, I have made 6 objectives to finish this tutorial series. We have done one objective out of 6 so far. Now we are going to do the second objective, which is called as ER diagram. ER is a short term of Entity Relationship Model. It is an example of a high-level conceptual data model. ER model indicates a graphical view of entities and their relationships in DBMS. In this tutorial, we are going to discuss entity types, attribute types, key attributes, relationships, cardinality, constraints. We'll discuss in next tutorial, and alternate notation. This ER model is based on 3 main components. The first one is entities, and the second one is attributes, and the third one is relationships. Entity. An entity is an object in the real world with an independent existence. Place, person, class, or it can be any object in the real world. An entity can also be an abstract, example, concept, event, holiday, etc. Entity set. A collection of similar entities called as entity set. Example, all persons having an account at a bank. Entity set need not to be disjoint. When we named an entity, we use a singular noun because the entity set of employee and the entity set of customer may have members in common. The first letter of each word in the entity name is uppercase. Example, student, customer, employee, likewise. Normally, an entity is named using a noun or noun phrase. Strong entity is denoted by a single rectangle. Weak entity. Weak entity depends on the strong entity for its existence. A weak entity is denoted by a double rectangle. The relationship between a weak and a strong entity is denoted by identified relationship with a double diamond. Strong entity may or may not have total participation in the relationship, but weak entity always has total participation in the identified relationship shown by a double line. Weak entity doesn't have a primary key. Instead, it has a partial key which can uniquely discriminate the weak entity. The primary key of a weak entity is a composite key, formed from the primary key of the strong entity and a partial key of the weak entity. The primary key of strong entity plus the partial key of weak entity equals to primary key of the weak entity. As in our example, employee ID plus dependent ID is the primary key of the weak entity. For further illustration, we have family as our weak entity. It is an overall group of dependents in one company, an entity set. Each family member in that family must be related into at least one manager. The cardinality of the identified relationship is either one-to-one or one-to-many from strong entity to weak entity. Attributes. An entity is described using a set of attributes. It is denoted by a novel. Domain of an attribute. The set of possible values that the attribute can have. Example, age. Integer values from 0 to 120. Name, 5 to 40 string characters. Composite attributes. Composite attributes can be divided into subparts. Multi-valued attributes. Attributes containing multiple values are called multi-valued attributes. It is denoted by a double line. Derived attributes. Some attributes can be derived, denoted by a dashed line. For example, age is derived from date of birth and current date. Key attributes or prime attributes. Minimal set of attributes which can uniquely identify an entity in the entity set. Primary key. There can be multiple key attributes called candidate keys in a single entity. A single candidate key designated as the primary key. Take a look at this example. Here I am taking an entity called book. It has three attributes. The first one is ISBN number, the second one is call number, and the third one is book name. All at once we can't decide which attribute will be the primary key of book entity because all of the three attributes looks like candidate keys. So we have to choose most suitable candidate keys among these three for as our primary key. In here, the most suitable candidate key is call number. Composite key. Sometimes a group of attributes made up the key. This is called as a composite key. In each normalization levels, we have to use composite keys to derive the tables. We are going to do the normalization part in our next tutorial. so don't worry about that. Super key or candidate key. Most of the DBMS people get confused about the super keys and the candidate keys. There is nothing about to say. Actually, it is all about confusing. But let's get clear. A super key may has one or more attributes which can identify a tuple uniquely. In an entity, all the candidates keys are super keys because all the candidate keys are chosen from the super keys. But candidate keys should not have any redundant attributes. For that reason, candidate key also called as minimal super key. That means it should not have any link with the other attributes. Please concentrate your mind into this example. Here we have student ID, student enrollment number, student name, student ID, student enrollment number, student name, student ID as our super keys. In this example, student ID and the student enrollment number are the candidate keys. Please make sure when you are choosing a candidate key, it should be unique and atomic. Relationship. Relationship is an association among two or more entities. Normally, a relationship is named using a verb or verb group. Degree of a relationship. Degree of a relationship is the number of participating entities in the relationship. Degree equals to number of entities. Relationship can be classified based on their degree. Binary, 2 number of entities. Ternary, 3 number of entities. Quaternary, 4 number of entities. Ternary relationships. Sometimes we need a relationship that connects more than 2 entity sets. If we located location entity in the department entity, it is quite like matching. Imagine that there is a company that usually transfers employees to several departments. So at the meantime, if anyone wants to check which employee is working in which department, it is better to store in a new entity. Cardinality. The cardinality ratio for a binary relationship specifies the number of relationship instances that an entity can participate in. That means the way that each entity reacts to their relationship. 3 types of cardinality ratios for binary relationship: 1-to-1, 1-to-many, and many-to-many. 1-to-1 cardinality. An employee manages at most one department. A department can have only one manager for managing it. One-to-many cardinality. A department may have more than one employee. Many employees may work in one department. Many-to-many cardinality. An employee can work on several projects. A project can have many employees working on it. Descriptive attributes. Attribute on a relationship. A relationship can also have descriptive attributes, which is used to record the information about the relationship rather than anyone in the participating entities. Start date is the descriptive attribute of this example. If we localize the start date on the employee entity, can you suggest a reasonable fact for that? No? So imagine that we are located start date attribute on the employee entity. Hereinafter, that information about the start date will relate or useful only to that employee entity. The most important thing is that we want to retrieve information or data efficiently. Here in case it will lead to slow data process. By all means, the department entity has the same type of a problem. So the start date on the relationship would be a good fit for that. Participation constraints. Constraint means quite like a restriction. Here I am cursorily talking about the participation constraint because they are a main constraint which I will looking forward to discuss in next tutorial. A student must be registered in a degree. Degree may or may not have students yet. If the relationship is not in a total participation, it is a partial participation. Total participation was partial participation. Each entity in the entity set must compulsorily participate in at least one relationship instance in that relationship set. In partial participation, each entity in the entity set may or may not participate in the relationship instance in that relationship set. Total participation is called as mandatory participation, and the partial participation is called as optional participation. Minimum cardinality symbol is 1, then it describes total participation. Partial participation minimum cardinality symbol is 0. Recursive relationship. In a university, the lecturer has given some assignments to the students, and he made several groups and appointed a leader for each group. So here we have an entity relationship diagram for that. A leader leads members. But the problem of this ER is both leaders and members are students. So we cannot make an ER like this. This is how we represent a student leads set of students in a group for assignment. This is a recursive relationship. A relationship between two entities of similar entity type is called a recursive relationship. Here the same entity type participate more than once in a relationship type with a different role for each instance. In recursive relationship, it is possible for the same entity to participate in the relationship. This is another example for recursive relationship. Here it will say, in most companies, each employee except the CEO is supervised by one manager. Of course, not all employees are managers. Alternate notation. Min, max. Used to specify the number of possible occurrences of each participating entity type in a relationship. It has two parts. First one, min. Second one, max. Min is represented by 0. Max is represented by 1. Min of the range denotes participating constraints. Max of the multiplicity range denotes cardinality. Let's look at this example closely. As I said earlier, alternate notation is the one for one participating entity. It is not represents both entities. So here we have an entity called employee, which has an alternate notation 0, 1, and there is another entity called department, which has an alternate notation 1, 1. Do you think that this is the complete alternate notation of this employee entity? No. It should be a combination of both entities, which means the alternate notation of employees, the constraint of its own, and the cardinality of department. And the department alternate notation is its constraint and employee entity's cardinality. Constraints of this relationship is 0, 1. Cardinality of this relationship is 1, 1. Read in the cardinality. Employee may or may not manage a department. He can at most manage one department. Read in the constraints. A department must be managed by an employee. I hope you gained something by watching this video. My next tutorial is about normalization. Hope to see you there.